with language model, I think everyone just standardized onto token representation of the words. But for physical movement, especially for dexterity-based movement, like, is there a standardized way of?
Not even close. It's very funny because you look at language, right? Language has been standardized for thousands of years. Every robot generates its own format of data, and it's completely different in many different ways.
You were at Tesla, you were at Google, you were at DeepMind, you were at Samsung. And all of these, they totally have different cultures and how they approach this problem, how they come up with solution. What out of all these experiences that you have had, which one has made the most impact for your own company?
Maybe the most salient one that was from the Tesla side was the importance of designing hardware and software together, where I think I had experienced some pain points in previous experiences.
It's so really hard for a business owner to wrap their mind around, like, what is the end result? What is the return on my investment? How do you talk to customer from this perspective?
It can't be like a 5%, a 10% improvement. It has to be in cost, right? It has to be substantially lower.
Now, if somebody come and ask you, like, how do I prepare my company for the future with robots? What would you suggest them?
Going from 0 robots in your facility to all robots is like extremely high risk and not really a good idea. Just because of these operational, like, little details that just, will make or break things. I think starting with like smaller kind of test things and simpler things that you can find out.
Hello everyone, welcome to Ai-Volution 2026. We are happy here at SCB 10X to welcome you to another session. So today I'm with Ben Eisner. First, let me introduce myself before I give all the light to Ben today. My name is Tanwa Apontip, Senior Advisor at SCB 10X. We are a venture capital firm under the SCBX Group in Thailand. We invest in cutting-edge technologies, AI, robotics, Web3, crypto, blockchain. Right? And today I have a pleasure of talking to Ben Eisner. Ben, how about you introduce yourself a little bit?
Sure. I'm Ben Eisner. I am a robotics and machine learning researcher, expert, and recently startup co-founder of a company called Index Robotics. We build physical AI, which helps manufacturers automate lots of delicate, touch-sensitive kind of tasks that require human labor currently, but we're going after automating.
And we have heard of this before, right? People have tried to use robot in manufacturing, but what we have seen in the past were robots that try to do cruder tasks, like moving boxes or moving shelves, that kind of thing. We have heard of Dexterious robot recently. Can you tell us a little bit of why right now is a good time for a company like yours to actually get into Dexterious robot? Like, what was preventing it from happening even 2 years ago, and why is it a good time now?
Sure, yeah. I would say the major step change has been on, okay, if you break down like when a manufacturer, say, goes to try and automate, say, a dexterous task, kind of historically what they have to do is they have to go down and look at that kind of complicated task. Like, let's say you're putting objects into a paper bag or something like that. And you have to, hire a bunch of engineers to go and, automate every single little possible step and every little edge case and every single sub-motion. And you have to also build a big contraption, a big piece of hardware to do this. So you'll go into factories and you'll see these very large machines that do what a human can do just sitting at their desk, but it takes a very large machine to do that. And that's just not cost effective. So there are a lot of tasks out there, these dexterous tasks, which could have been automated from a physics perspective, from a science perspective, for a long time, but not from a cost perspective. And so what's really changed in the last, I would say, 5 to 10 years, it depends on when you start counting, is that more general purpose hardware is becoming more and more capable, both from just a pure hardware perspective, but also from a software and intelligence perspective, using machine learning algorithms, learning from data, learning by watching and doing and improving, rather than having a team of engineers sit down and design every single little step of a process. So that's kind of what is this massive step change, in my opinion, and what's what's going after these dexterous tasks.
So it was possible before, it just wasn't cost effective for people to go into.
Yeah. There's some tasks where it wasn't possible at all, right? There's very, 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 very granular kind of like knitting, sewing, some kind of like small parts manipulation stuff. That just wasn't physically possible. But you'd be shocked when you go to actual manufacturing sites in the world, how many tasks you're like, I've definitely seen a robot doing that before. But there's humans doing it in that factory, like just taking a couple boxes and loading them into a machine. Like there's ways to kind of design robots to do these things. They just aren't cost effective, and that's a huge fraction of it.
I saw a video online of a robot actually just doing one task, which is flipping puzzles over, right? Because puzzles come in different sizes and shapes, and it's like some in a bag, some in a box, and it's just like apparently it's a very difficult thing to do, and people still use human for it.
Yeah.
Now, of course, you saw this opportunity. I assume part of it was because you were at CMU doing your PhD at Robotics Institute. Now, you mentioned that this change in hardware capability and cost optimization happened in the past 5 to 10 years. But for you personally, like what did you see that made you go, instead of being a researcher, I should go and do a robotic company?
Sure. So there were a couple moments. I think the big one everyone's familiar with is like the ChatGPT moment. One of the big problems in robotics is kind of understanding what's happening in the scene and understanding semantically, what needs to be accomplished for a task, right? Somebody tells me to open a bag, and that kind of implies in my brain I have like general intelligence that, okay, I need to grab the bag, and these are all like kind of, and open it and peel it open and put things in. And these are all kinds of, abstract kind of intelligence concepts that roboticists have struggled for many, many years to encode, and it's like very, very painful to design. And the ChatGPT moment was like, okay, actually, we can just give a very basic text description of a task, or we can give images or a video recording of the task, and it won't necessarily know how to do it, in terms of controlling robots, but it understands like the kind of capabilities, really understand, the capabilities to understand these scenes and what's going on have really matured a lot. I think I heard a term recently that was I think pretty salient, which was like kind of model market fit, where it's similar to product market fit, where there comes a time when models eventually get good enough that they can start to address market problems. And for robotics, that was just not possible for a really long time. There's two main pieces of robotics when there's like understanding what's happening in the world and understanding what to do in the world. And that understanding what's happening in the world, I think we have model market fit now. Now, what to do, actually, like how to control your arms, how to control your hands to do these tasks, that is where like my own research and some of my peers, we don't think that those capabilities are as close to ChatGPT as we'd like them to be, but in much more targeted domains. We're really confident that what to do in these dexterous situations is like on the precipice of being solved. That's.
And I could totally see that, like, with language model, I think everyone just standardized onto token representation of the words. But for physical movement, especially for, dexterity-based movement, like, is there a standardized way of?
Not even close. No, I mean, it's very funny because you look at language, right? Language has been standardized for thousands of years, right? We have characters or words. These are like things that can be represented by computers very simply. Even Unicode, right? It's like 40 years, maybe 40 years old. I don't know. Images, right? This standard representation of a grid of pixels, right?
And colors.
It's like and colors. It's like 60 years of agreement across the entire world, right? Generating this data. Every robot generates its own format of data, and it's completely different in many different ways. Every new sensor, we care a lot about touch sensors, and those sensors are completely unstandardized. There's no agreement as to what information should come out. So, when you talk about these large language models, large vision models, they benefit from this like standardization of a large corpus of diverse data that's been generated over 60, 70, 80 years. I mean, and then put it on the internet. But robotics doesn't have any. Doesn't even. Not only does it not have the data, but it doesn't even have the standard to kind of source this kind of thing. And then controlling a robot that has 2 arms versus 1 arm is like almost a complete. It's like speaking 2 different languages.
And then the axis of movement.
Yeah.
But doesn't that makes it sound like that's a low-hanging fruit, right? Like why don't just all the robotics companies just I don't know.
Yeah, exactly.
I'm an optimist, right? Everyone should just band together and just standardize on how to talk about movement, and then we can scale into it with compute. Like, why is that not the case?
I think it's really hard because first, I'll say that there has been some effort over time to do this. Like the ecosystem has matured in some ways.
But I want to tease this out a little bit more. Is it hard from physics perspective? Because my background is a physicist, right?
Yeah.
So I know from physics perspective, you could define any movement with tensor, and everything would be well defined. Or is it hard because of like industry and people being tribal about their technology?
There's definitely elements of both.
Okay.
On the physics side, I would say the difficulty actually comes from the fact that, and we're getting a little technical here.
Oh no, go ahead.
Yeah, but the like contact and motion, especially when there's multiple kind of motors in a sequence, right? Like a tiny change in the dynamics of your shoulder, let's say, has a big change at the fingertip.
Right.
Right. So small differences in the shape of your robot means that an action that looks like one thing on one robot will have a completely different effect, which is very different from language, right? Like language, you have a whole paragraph and you change one word in the paragraph. Usually, unless like a very, very important word, usually the meaning is the same or very close to the same. In robotics, right, like in these control settings, they're very chaotic, right? Like so you're grabbing a water bottle and your thumb just kind of like swings out for half a second, you're going to drop the water bottle, right? Completely different success failure. So that's the technical answer. It's just a completely different kind of data compared to language and vision. But on the kind of collective action problem, I think the problem is 2 things, and one of them is improving, one of them is not. The thing that's improving is that there's a huge amount of energy and momentum behind this right now. Like the last couple of years, we've seen just an explosion of interest in robotics, right? Like the humanoids kind of kicked off this new generation of like, oh wow, we're finally...
We might not have to work anymore.
Exactly, we're finally in the future. But I think that, as well as a lot of the AI advancements, and there's been tremendous global investment in the ecosystem, has meant that there's been more standardization. There's more companies popping up because designing and like kind of agreeing on these different things presupposes that the manufacturers of the robots themselves have even designed the robots to have this kind of standardization, right? Like if you're using a robot from a particular type of company, they might be used to very traditional manufacturing processes, and they don't, there's no ecosystem or development around it. It's kind of like a long tail of problems to get to that level of standardization for data ingestion, data collection, things like that. There are open source ecosystems that do this. Like RaaS is the famous robotics operating system kind of ecosystem. It's been around for a long time, but wasn't really purpose built for kind of the intelligence era with in terms of like controlling very high degree of freedom object like robots and doing dexterous things. Yeah.
Let me sum up this section
Sure.
in a way that I understand, just to make sure I understand. So standardization of robotic data is hard because of 2 things. Like one is that it is actually really complicated from physics standpoint to standardize it. For example, you can tell 2 people to take a step. Now the person who is taller, the step size is going to be larger.
Exactly.
So then to standardize the physical movement of a robot, you need to take into account the whole thing of the robot, how it thinks, how it's constructed, the dimensions of it. And that makes it difficult from physics standpoint. Now from the business and industry standpoint, robotic doesn't get the benefit of a long history of standardization.
Exactly.
Unlike language, right, which we have totally standardized it into this digital format that everyone's using. Fascinating. Now you have long history in robotics. Right? You were at Tesla, you were at Google, you were at DeepMind, you were at Samsung.
Yeah.
Right? And all of these, they totally have different cultures.
Yeah.
And how they approach this problem, how they come up with solution. What out of all these experiences that you have had, which one has made the most impact for your own company? Like which one you bring with you and be like, we're gonna steal this principle?
Yeah, well, we're not stealing any principles. No, but I would say it's a split. I've learned something from every kind of these environments I've been at. I think maybe the most salient one that was from the Tesla side was the importance of designing hardware and software together, where I think I had experienced some pain points in previous experiences. In research labs where you buy a robot from somebody else, right? And then you try and control it, and yeah, you can do basic things, but oftentimes, if you haven't like built and have the in-house expertise around a lot of the hardware components, it's very difficult to, once you hit some limit, it's very difficult to push past that limit if you don't like have the ability to modify and change your hardware stack. An example here is like, let's say you have a robot arm and you want it to move a little faster than the manufacturer originally intended. If you don't control the design and you don't control the API, like maybe you can have a partnership. You're either out of luck or you have to wait weeks or months for the manufacturer to like respond and make changes, right? Whereas at companies that do their own kind of co-design, right, where you have in-house talent to do building. You don't have to build the entire thing, right? It would be crazy to build every single piece of the robot down to every single chip. That's just not, there's a reason that there's specialization in the marketplace. But certain elements, especially like the geometry of the hardware, like the end effectors, the hands, the certain aspects of how the motors move, certain aspects of the computers and the sensors, like there's a real benefit, a really strong benefit, because we don't have this standardization, because the ecosystem is relatively immature. Normally, I think in startup land, you would probably advise people not to build too many things in-house, because buy is a safer strategy than build in a lot of cases, except when it really makes a big business difference, right? And I think in robotics, that's actually the case, that there is still a big trade-off where you need to decide buy versus build, but having both the hardware and the software in-house for a lot of different tasks is actually a pretty major differentiator, and it allows you to move a lot faster, and I would say achieving kind of success with a customer goes a lot faster, right? Like you can go to a customer and you say, here's the robot prototype that we have. Oh, you need a slightly smaller finger size, right? Like for your I don't know, let's say you're grasping a different kind of vegetable than we've encountered before. Okay, that makes sense. We'll modify the hand a little bit on our side, and we have the capacity to do that instead of having to say, "Oops, sorry, we buy our hands and they don't make one for your task." It's there's a lot of those kind of like little plugging gaps in flexibility that are really important to have in the robotic side.
So it sounds like there are 5,000 things that the customer has to think about when buying a robot for their work, and that sounds really hard, because I don't think anybody in the world right now, because the technology wasn't there before, I don't think anybody in the world right now has the knowledge or experiences to even vet this kind of deal. Like if I'm a business owner and you come up to me and be like, this robot is really amazing, you should test it out. The first thing I'm gonna do is I'm gonna say, okay, go do that thing, go pick up the carrot, right? And then your robot will pick up the carrot correctly. Now I'm gonna be concerned about maintenance, like future changes, blah, blah, blah. And then all of that usually come down to the ROI of the investment, right? So for a deal like this, it's so really hard for a business owner to wrap their mind around what is the end result, what is the return on my investment. How do you talk to customer from this perspective?
Sure. In automation land, there's usually kind of two value propositions that you might choose. One is I can do it faster and better than a human, and that's just like such an easy value proposition, right? You've seen robots that can, I don't know, place chips on a circuit board, right? That they go like, extremely fast with extremely high precision. And that's like an obvious, like you can just sit down and write on a napkin, like I'm doing this, it takes your humans, human workers this many times, and they make this many mistakes, and actually we can go 10x faster and 10x more accurate, right?
The potato selector, basically.
Yeah,
right?
exactly.
You just kick out the bad potatoes out of the lot. Yeah.
These very specialized things. There are a lot of tasks where, and this is kind of actually where a lot of the kind of general robotics is going. Most of them are not really aiming to go superhuman. Like just matching human level performance is enough of a sell, or close to human level performance even. But at that stage, you were talking about kind of like risk and kind of how do you make it worth a company's while when there are real risks of the technology being new or something like that. And the answer really is that you have to have a huge ROI, right? Like delivering costs which are like less than 50% of what it depends on what you're delivering, right? If it's a dangerous task, you can say, okay, it's worth their while. If it's more, if it costs a higher fraction of a human worker to do the task. But for most tasks that are that we're looking at, these very safe, not so. They're critical to the business, but not like to safety or anything like that. You need to deliver a pretty major ROI to compensate for what you just described, which is that like some of the technology is relatively nascent, and you're right that the operational headaches, even older technology, even like traditional automation, which is really mature, and there's really mature ecosystems for distributing, for integrating, all these things. Even they have the same like hurdle to clear, right? Because every time you make an investment in hardware, it like restricts your ability as a company to change, right? Like if you're a potato farmer and you buy a big potato machine and you suddenly want to grow carrots next year, like
you're stuck with potatoes.
You're stuck with potatoes, yeah.
You're going to be a potato farmer.
So basically all this kind of comes out and says that it can't be like a 5%, a 10% improvement. It has to be in cost, right? It has to be substantially lower. When you actually go to customers, I think especially like the smaller company, like there are many integrators that have long relationships with customers, 40, 50 years. They've been helping them, they've been in the industry, whatever, in very specific verticals. For smaller, younger companies, the trust building is very much, what you kind of said, is like you kind of have this ratcheting step of like, demonstration, evidence, proof, trial, and then repeat and grow the size. And you often have this kind of an informal agreement of some sort. But that's how you build the trust, is like through evidence.
And that's really insightful for the business owner out there. If you're looking for a robot or invest in a robot, right? You don't want really small margin. Because from my experience, when I talk to people who try to buy a robot, they don't think of the second order changes that they have to make. Like if you buy a robot of a certain size, and let's say you are a retailer, now your aisle can be too narrow.
Yeah.
Right? You're stuck with that size forever. And then you have chargers, you have people, you have operational changes that you need to have. Like what happened if a robot fall down? What happened if a robot fall down on people?
Yeah.
Right? So you're not gonna look for small margin when you talk to a robot company, and that's what Index Robotics is trying to deliver.
Yeah. It's tough. I mean, that's historically, when we talk about margin, like where is the cost coming from? Historically, the difficulty is in all those engineering hours to have somebody sit down and understand your process and design the process. It's funny enough, it's actually not the robot itself. Like the actual metal and the plastic and circuitry is not the expensive part of robotics. It's very much the like process of you might spend X dollars on the actual robot and then like 2, 3, 4X over months on the actual integration. That's not true for every task, but for many of these tasks, it can be something like that.
Now, for an enterprise right now, if they are buying or selecting LLM providers, I think it's almost equal across the board. Right? They can use anyone, and it's easy to switch out. But as we were talking, if you select a robot, right, it's really hard to switch out once you have solidified on a particular choice. But how would a customer balance choosing to buy a robot right now rather than waiting 5 years, 10 years from now? Because it's really hard to project the growth of the technology, right? Nobody could have seen ChatGPT. Some people did, but most people couldn't see the onslaught of LLM in the past few years. So what would you say to a customer? Like, when is the right time for a customer to say, let's get a robot right now?
That's a good question. I think it's difficult to like say in absolute terms because there's so many different types of tasks, and there might even be, as I mentioned, model market fit, which is that the capabilities, the technology might exist, but execution is very difficult. So I think there's things that customers can do to kind of de-risk a little bit on this. Like instead of, I think there are a lot of different business models in the robotics world about doing this. The kind of hypey one that people really wanted to go to is like robotics as a service, RaaS. That's the big buzzword. At least last year, it might be this year too. Which kind of changes the calculus from I need to figure out how to own and finance a very expensive piece of equipment into actually I can have this kind of service contract which maybe has longer lifetime costs than an upfront capital purchase, but it gives me a little bit more flexibility in terms of getting out of it if it's not working. Importantly, that's not possible when you do a lot of custom engineering work for a client. But I think this is the interesting change in like this. I'm not necessarily saying general foundation models for robotics, but more general purpose hardware that's doing more. There's been these humanoids, which I don't know if I would recommend a humanoid in most customers' facilities today, but it's a general purpose robot. And these robot arms, especially the ones that we have experience with, they are quite general purpose, right? You can, with the right programming, you can put it in a factory, you can put it in the field, those sorts of different things. There's a lot less kind of CapEx risk on that, because if they're much more amenable to these kinds of recurring revenue sorts of arrangements where there's less of an upfront capital expenditure. And that's like one way that customers can kind of think about this in terms of like, should I wait or not? If like a customer, if a provider isn't like causing you, a robotics provider isn't causing you an enormous amount of grief, right, to do the integration, there's ways to structure these so that it's not this like massive financial risk up front. It still might disrupt your operations if you like, this is like any automation or any kind of integration problem. Like if you have a problem, you have a problem, right? Like you can't avoid there being bumps on the road. But yeah, I think, it's tough because a lot of companies are also, very used to capital investment, right? Like factories, they know how to structure managing risk and managing, going to their lenders, right? And saying like, yeah, here, I'm going to buy this equipment and like I know exactly what the resale value is, I know exactly what it's going to produce, and like assuming that I'm able to sell this many units of my product, then like it's a very safe bet. So they are more familiar with that than the kind of RaaS models. So there's kind of a mismatch here. I don't know if this answered the question for you.
Absolutely. Because it comes down to, I think, unique situation of each of the business owner. Right? Are you comfortable with the capital expenditure right now to acquire this new piece of equipment and then test it out? So I think eventually it comes down to your earlier answer, which is like, is the ROI justified?
Yeah.
And by justifying, you should be looking at like half the cost or like 2x the revenue. Right? Unless you can see that, might as well just wait out.
Yeah.
Right? Now, I want to take this in another dimension entirely. Like now, let's say we don't talk about ROI. Let's say we don't talk about like how do we do accounting for the robot purchase. What if we talk about just from feature of the robot, right? Is it fair? In my mind, I always think about like, what if? What if I was a business owner, right? What if I was a business owner and I want to buy a robot and I'm not sure whether it's gonna work? It works now, obviously, because ROI is great, but should I buy it now, go into the future? I always think I would prefer hardware capability that answer my problem right now, even though it might not perform to the level that I want.
Yeah.
So for example, I might be willing to buy a hardware that reduce my cost 20%, right?
Yeah.
Not the 50% that we talk about, but with the hope that the physical model can do the speed that I want, just the software cannot, and just bet on software improvement. What do you think on this, like the hardware and software feature trade-off?
Yeah, I mean, I think there are parts of the robot where that makes sense, and there are parts where it doesn't make sense. So I would say it's kind of like, what needs to improve more in the next few years, next decade, whatever, to achieve the level of capability that we all dream of, right?
Which is to do my laundry.
Yeah, exactly. Which, actually, I mean, today you can probably, some of these frontier model companies have shown that if you give the robot enough time, it can maybe do your laundry.
Yeah, but then I have to finance my house to
Exactly. Yeah.
A robot that can do a laundry.
No, yeah. I think that there are parts of the robot stack where the hardware is less important and parts where it is more important.
Okay.
Especially in manufacturing settings where there are safety concerns, but you're also kind of working with there's friendly people in your factory, right? Like it's people that your employees, your staff, who are trained, who understand the risks and understand the capabilities of robots. So like a robot arm, which is a bit heavier and a little more dangerous, is not, if you contrast that with being in the household, like there just do not exist really safe household robots that are very big and capable. So if you were saying in the household right now, you need to I would not buy a robot and put it in my house right now and just hope that the software gets better. In a factory, maybe some of the robot arms you can repurpose because again, they're capable of doing a lot of the tasks. What I would say is that a lot of the sensing and a lot of the end effector, when I say end effector, I mean it could be it's the thing that the robot uses to interact with, it's the end of the robot that affects a change. Yeah. So that could be it could just be sometimes you just poke something, or sometimes it's just a pincer, right? It's like one motion. Sometimes it's a human hand, right? That's the kind of thing where there's been a lot of innovation and interest in the last few years, and things are changing really, really quickly. So that's the piece of the hardware stack I wouldn't say make upfront investments in. There are robot hands that look like a human hand that cost $200,000 US, and that's I don't think that's a good investment for a factory to say just in 5 years they'll be able to control it finally, right?
Because they have been saying that for the past 15 years, right? And
exactly.
We still don't have dexterous robot hands.
Exactly. Yeah. I mean, the intelligence stack is going to get better. I just don't. I wonder if it'll get better for everyone uniformly, or if it will be much more vertically integrated. So there's a massive platform ecosystem of hundreds of different robot arms and different end effectors and everything like that. I kind of think that I wouldn't. It's a little risky to bet on buying my hardware in advance and then hoping that the intelligence comes, because I think a lot of the next 5 to 10 year solutions will be a lot more vertical, fully integrated. So somebody somewhere might have a robot which has the capabilities, and it might look like the robot you own, but we're talking about data standardization, right? They just might not want to support. I don't think that there's going to be one kind of turnkey robot intelligence solution that you just throw on any robot with no, investment whatsoever, and it just works in the future. Yeah.
Makes sense. I mean, have you read the Frankenstein, not the movie? I'm going to tie this back to his answer. Yeah, you're going to be shocked how I tie it together.
Yeah, it's been a while, but I think
So in the Frankenstein, the book, not the movie, the body of the monster is actually really powerful. Right? Yeah. He can do long jumps. He can jump across a river. He can run really fast. He doesn't feel heat. He doesn't feel cold. So that's really good hardware if he's a robot. But he has subhuman intelligence, right? So that makes me think of your answer. Made me think of the Frankenstein. You can have the best hardware, but if your software is not vertically integrated at the creation with the robot, you cannot change it. Right? Regardless of how good your hardware is, it's still going to be Frankenstein.
Yeah, I mean, a great example of this is when we use in the company is you might, and the other way it goes around too, right? That you might have excellent intelligence, right?
But if your body doesn't move.
Yeah. So if you've ever tried to tie your shoes while wearing gloves, right? You have human level intelligence. You can control, you can do it, and it may take. You can eventually maybe do it, but it's just. You don't have the hardware. to do those tasks, even with the same like the strong intelligence. Yeah.
I have slippery hand. I know
Yeah.
exactly what you're talking about. Like,
Yeah.
I would go to a restaurant and embarrass myself all the time. Let's talk about scaling a little bit.
Sure.
In language model, there's always an obvious scaler, right? If you have more GPUs
Yeah.
and you have more data, you are likely going to win. Like, it's clear. In robot, is there something similar?
I think yes.
I don't think having more motors would make sense.
Yeah, no, not scale. You don't want to scale the body of the robot. I think the scaling comes. There's two different kinds of scaling. There's capability scaling, and there's like operational scaling. A lot of people have somewhat good answers to capability scaling. Operational scaling is a I'll talk about in a second, is another beast entirely. Capability side, I think. It's actually not so different from a lot of the LLM, modes of operation for scaling. Actually, self-driving is probably the most salient example here, which is scaling involves like more deployments.
Okay.
So when we're talking about if you need new capabilities and you want to use a data-driven approach rather than just hand engineering different things, you need real-world interactions and expertise from a robot, right? Like a robot needs to go into a situation and either have a human control it, or it needs to figure out on its own somehow new information. I think that the trick on scaling in robotics, though, is that like quality is not equal to quantity. Where perfect example is here, right? I could sit at my desk and shuffle papers every day on video for I don't know, a year, right? And that would generate many tokens, right? But the amount of new information you get from each additional piece of data is very low. And the LLM and VLM world, like the language models and vision models, they benefited from the fact that the internet was already extraordinarily diverse when they got there. But in the robotics world, like there is no internet of data. And if you just sit down in a room and try and collect data by yourself without any real world interactions and on artificial tasks, like you might get a large quantity of data, but the quality is just not, the diversity, right? You need diversity to kind of like, this is how humans learn, right?
Right.
Like, humans need new experiences. They need to try and fail, and I think a lot of that is about diversity of experience. So scaling success for robotics, I think, when we're talking about capabilities, has to come from like more robots in the field in different situations, even if they're not doing the 100% perfect job. Like there are some companies right now that are doing kind of teleoperation based scaling, right? Companies where they just have the robot is in a space and then they have a human kind of on a different, in a different site.
Teleworker,
Teleworker kind of controlling the robot. And I think that's a totally solid way to do certain kinds of scaling. I don't know if I would necessarily do that a lot in industrial settings. It's kind of a drain on productivity in a factory to do that, but that's one way to scale the capabilities. Operationally, I think it's a very different game. When we talk about operations, I mean like getting the robot to the customer, making sure the robot works for the customer, building supply chains and support networks to make sure that the customer continues to succeed, right? Because when you're selling robots to customers, you're not, almost never are you just like giving them the robot and saying bye, never talk to you again, right? You're selling a solution to their problems, and that solution is a physical one, and it requires maintenance and an ongoing relationship, and very different from software, where somebody can be sitting in San Francisco and just get on a Zoom call with somebody in Bangkok and like solve their problems remotely, and it's a total software change. This doesn't work in robotics. So the scaling is slower but more powerful in some ways, right? Like you can think about different verticals within the robotic space, and you can there's the scale is often around operational competence. I think is like that's a problem. It's more of a business problem, and it's kind of people get obsessed with capabilities, but that scaling one is the one that has had a has made or broken a lot of different robotics companies in the past. Yeah.
Perfect answer to the last question that we have. We're about to run out of time, but I would really love to ask this question. when people ask me how do they prepare their organization for AI, I would be like, well, are your documents AI consumable? If they are all in scanned PDF images, then you need to change the way you work. Like, can you write it out in a way that's AI consumable? Now, if somebody come and ask you, like, I'm not ready to buy a robot. I know the robots are coming. How do I prepare my company for the future with robots? What would you suggest them?
That's a tricky question. I think what we've seen be very most successful is kind of like getting into automation a little more incrementally.
Okay.
In terms of, I think going from 0 robots in your facility to all robots is like extremely high risk and not really a good idea. Just because of these operational little details that just will make or break things. I think starting with smaller kind of test things and simpler things that you can find out, okay, how do I build relationships with providers? How do I train my staff to know how to interact with robots? Maybe not these more complicated dexterous robots, but even a box folding machine. These are machines that you can buy. There's kind of a standard language around integration and figuring out, okay, how do I what kinds of contract do I even need with my provider to make sure, and how do I vet whether they're going to be there on time to make sure my operations are still there. So I would say that there's not a huge amount that comes to mind in terms of preparing your data or you're preparing your workers to interact with the particular form factors or UI or teaching, training, whatever. I think it's a little too premature, and that's very case by case right now. There's not some general advice. But in terms of becoming operationally competent, I think thinking about how to structure relationships with your providers so that you accomplish what you need in your business, right? What KPIs do I actually need to hit? Because actually this is an interesting thing. When we're in the early stages of starting up, we talk to a lot of people, and a lot of very small producers, they have very little automation, and they can't even articulate what they need out of a robot, right? Because they just ask a human to do something, and they just figure it out, right? And that works when it's just humans. It doesn't work when it's robots, and I don't think it will work with robots for a while, maybe eventually, but right now you still need a lot of those kind of very specific business targets, right? I need 99% success rate with 10 units per second average throughput, right? If I'm doing a picking task, right? And even having those, knowing what kinds of uptimes and reliabilities and things like that, that sort of internal introspection about the business and understanding which pieces, if this were to fail for half of a day for maintenance reasons, is that okay? Right? With humans, right? If you have human workers, somebody gets sick and have to leave. There's a gap, and you can just put another human in that gap. So on short notice usually. But that's a little harder.
Love it. So knowing exactly what you want out of the automation,
exactly,
right? If you want a robot that can do your laundry, what if it can fold all of your laundry? Is that acceptable? Is 90% acceptable? What if it takes 8 hours to do it, right? These are the kind of things that you can think about ahead of even buying your first robot. Love it. Lastly, Ben, we're really out of time. If people are interested in learning more about you, Index Robotics, where should they go?
Good question. In a few months, I think it might be, before we have any kind of public interest. I have some contact information for specific manufacturers if they want to get in touch that I can provide after the fact. But
and of course, Ben is on LinkedIn.
Yep, I'm on LinkedIn.
Yeah, you're on LinkedIn. Yeah. You can look him up there.
Yeah.
And, all right, Ben, it's been a pleasure today. We learned a lot, and hopefully we can get you back for the next Ai-Volution.
Sure, yeah, it's been a pleasure.
Thank you to our audience for joining us today. Signing off. Thank you.
Thanks.